Welcome to the Rare Earth Exchanges podcast, where power, politics, and the world's most coveted materials collide. Rare earth elements power the backbone of tomorrow's most critical technologies. With China dominating global production, the U.S. and its allies must align strategically to ensure a stable future. This urgency prompted tech entrepreneurs Daniel O'Connor and Dustin Olson to launch Rare Earth Exchanges, a news and insight platform built to equip stakeholders and decision makers with the tools and intelligence needed to reduce dependency and build prosperous resilience. Let's get into it.
Hi, everyone. Welcome to the Rare Earth Exchanges podcast. You're joined by me, Dustin, my co-host Daniel, and we got three special guests with us today. We've got Paul, we've got Kimberly, and we've got Sarma. And there's a lot to unpack here. So to get started, let's have a brief introduction about who you guys are, who you work for, what your role is there. And Paul, let's start with you.
Very good. Thank you, Dustin and Daniel. Appreciate the invitation here. So my name is Paul McCloskey. I am Vice President of Energy and Business Development with Clearly Ahead Development. So we're an economic development group. We focus on one of 67 counties in Pennsylvania. We're in Clearfield County, Pennsylvania, and we're trying to help get the rare earth element industry in this region off the ground. We've got some upstream providers, we got some machinery manufacturers in the area, and so excited to talk about what we're doing here and how we can work together to help bring this industry to fruition here in the United States. Thank you.
Awesome. And Kim might be on mute. Yeah, Sarma, why don't you tell us about you and then we'll come back to Kim.
Yeah, I'm Sarma Pishapati. I'm a professor of energy and mineral engineering and chemical engineering. And I also direct the Center for Critical Minerals at Penn State University. And we do a lot of research as well as in cooperation with industrial partners, we are trying to extract these rare earth elements from legacy coal mining, I should say, legacy coal mining refuse or acid mine drainage, and show that yes, we can extract these things and make the final products within the country without exporting any of this without exporting any of this material to outside for processing. So our goal is to establish 100% domestic supply chain here in the United States, and we are building a pilot scale demonstration unit with money allocated by Congress to treat about 10,000 gallons per day of acid mine drainage and to extract both critical minerals as well as the rare earth elements, 17 rare earth elements. That's the role that I'm playing right now at Penn State University.
Fantastic. And then, see, Kim, do we figure out your audio?
Hi, this is Kimberly Portia. Can you hear me?
Yes,
Yep,
we can hear you.
All right, awesome, great. I'm Kimberly Portia. I'm a professional engineer and a director of program management at Tetra Tech. And Tetra Tech is an international engineering consultancy. And my role is to lead a group of project managers, and also I'm a project manager myself. I focus primarily on what we call sustainable energy and resource recovery. Specifically to this topic, I've been working for about the past 7 years on developing a facility that will upgrade sources from abandoned coal mines into rare earth elements and critical minerals to their base metal.
Wow. Sounds very impressive. That's awesome. Great. Well, we got some questions for you, and I'll let Daniel kick those off with learning more about what you guys are doing, and we'll go from there.
Yes, thanks. Thank you, Dustin. Thank you, everybody, for joining. Part of this, we really wanted to celebrate this coming together, across Pennsylvania, which has a significant mining legacy in our history. And you have the academic center, right? Sarma. You've got an economic development effort clearly ahead with Paul, and then Kimberly with the private sector, and there's some Department of Defense or Department of Energy, I believe, grants about $5.3 million for this pilot. And I think it's really exciting. We wanted to showcase what you all are doing because it's important that people understand that there are initiatives emerging across the country to try to help us transcend this current situation, which is not good. Okay, it's not good. With this to start off, I think, I'd like to get the perspective first of Sarma. From your vantage, I think this is important. You're working on the prototype at least some prototypes for pilots. Okay, and I think there's a couple thresholds to break. One is, of course, can you do it, and the second is, can you do it economically? So from your standpoint, the good, the bad, and the ugly, what you've seen so far, how do you feel? How far away are we from taking, for example, use coal or what have you, processing that into the rare earth output that we need? What's your perspective on that?
Sure. I mean, this is a very important topic, as you mentioned very clearly, and we do have a lot of secondary resources like acid mine drainage, or even now the acid mine drainage is treated at some locations by the state, by some base, sodium hydroxide or calcium hydroxide or lime. And what they do is they bring the pH to about 7, which is the neutral pH. And at that pH, the water is discharged into streams. And these elements, precious elements that we are talking about, precious metals, are precipitating at that pH, and they settle down to the bottom of that pond. And once in a while, maybe 2 weeks, maybe 4 weeks, they take that sludge that has settled at the bottom and discharge into another pond, and it has been sitting there. Because that sludge that is there is a mixed bag of sodium hydroxide, sodium or calcium or whatever, plus iron, plus aluminum, plus rare earth elements, all the transition elements that we have, critical elements, everything. To separate those elements, it is not an easy task because it has already been treated to a pH of 7. To dissolve them, we have to go back to a pH of 2, which means acid consumption and so on. The lowest hanging fruit, the way we are seeing it, is the acid mine drainage itself. When it comes, it is coming out at a pH of 3, 3.5, depending on the source, or sometimes higher. So instead of adding sodium hydroxide and precipitating everything, we are doing that in stages, because some of these elements come out at a pH of 4, some come out at 5, some come out at 6, some come out at 7. So what we are doing is, instead of dumping all of the base at once, we are also using an environmentally friendlier base, which is sodium carbonate. And what we do is we are controlling the pH at about 4 to precipitate most of the iron, which is the first one that comes out. So we filter that iron, so we got a concentrate of iron precipitate, and then we add a little bit more of this sodium carbonate to raise the pH to about 5. At a pH of 5, we get the aluminum products mostly out, precipitates out as a hydroxide, so we filter that out. I'm not saying it is 99% or 99.99% pure, but it is at a very high concentrates of these elements there. And then what we do is we filter out that aluminum and then raise the pH back again to about 7, where all these rare earth elements will precipitate. Whatever are present, it, in some sources it could be higher neodymium, or in others it could be higher scandium. Scandium comes out at a lower pH, but different elements, depending on those. All those rare earth elements, basically 17 of them, 15 lanthanides plus 2, will come out at a pH of about 7. Not scandium, but and then what we do is we filter out those rare earth elements. Now the water is at 7. Technically, it meets the regulations to discharge the water. That's what active treatment plants are doing at taxpayers' dollars right now. Most of them are taxpayers from abandoned coal mines. Active coal mines, it's regulations, they have to do it now under new regulations, so they are doing it. So what we have developed at Penn State is a technology. I mean, if cobalt is not coming out completely, manganese and nickel are not coming out at a pH of 7. They are still in the water, which is going out into the streams. So what we are doing here is we have developed a unique process where we can get those metals. Typically, if we have to get those metals, we have to raise the pH to about 9 or 10, which means we are adding more sodium hydroxide or more sodium carbonate or whatever it is, and at pH of 9, 10, 11, we cannot discharge the water. So we get these elements, but we have to bring the pH back again to 7 by adding a little bit more acid to it, and then let this water be discharged into streams. What As I said, what we have developed is we have developed a technology where we pump ozone through it at a pH of 7, not raising it to 9 or 10. We can precipitate cobalt, manganese, nickel, and even other transition elements that we can get them out. So after rare earth elements, we separate at a pH of 7 after ozone oxidation, all these metals, and then discharge the water at a pH of 7. So we are avoiding that extra base as well as acid, which is making more environmentally friendly as well as supposedly cost effective.
So, sorry, Sarma. So basically, and then it sounds like you're working with existing processes. There's existing taxpayer sort of funding for these processes, and you're finding a way through this circular economy innovation to separate certain key rare earths out. This is good. I want to come back to that, but I want to move to Kimberly for a second. Now,
Sure.
This process, Sarma and Paul, we'll get to you in a minute, that you are working on. Kimberly, your company secured a grant from the government to help, I think, with a proof of concept or pilot. Could you talk a little bit about, does that dovetail with what Sarma's talking about? Is it related, and how that fits into the Pennsylvania landscape? Again, Kim, part of the theme here is organically in Pennsylvania, folks are coming together to try to solve this problem. And we want to highlight this. It's very important. Go ahead, Kim.
Yes. So actually, we have been working with the DOE for about 12 plus years on this particular issue. The first of which is we were kind of just identifying the sources of where these rare earths are. The next of which is we put together a concept study. Overall, it's been about, for Tetra Tech, my involvement, about $8 million in grants. And we start with a concept study, and we determined that one of the higher sources of rare earth and critical mineral attributions was located in Clearfield County. We have really good relationships with the community and the mining community there. So it just seemed like a really good partnership to basically center a project in that region. We have been working on utilizing existing commercial equipment to develop our process train. So we actually, in our previous grant, which was a feasibility study, which was about $2 million worth of federal funding, we built the first 2 phases of our pilot plant. This pilot plant is in Washington State. And within that feasibility study, we actually took the clays from this area and ran it through the first 2 stages of our pilot facility. Those first 2 stages are physical concentration and chemical extraction. So what that does is it breaks down the clay material, and it extracts through a traditional hydromedical process of acid baking, water leaching, and precipitation. It extracts out a mixed rare earth oxide. Now, currently in the United States, that is the extent to which our rare earth elements get processed. So Mountain Pass is one of the only rare earth mines within the United States, and that is the level of their technology currently and equipment that they have currently operating. And then what they do is they sell those mixed rare earth oxides off to market, which essentially gets shipped out of the United States to China to get separated and then reduced into the base metals. So this part of our grant, we've actually now designed and procured, and we have commenced operation of our 3rd phase, which is the separation process. So this is the process in which we use a liquid-liquid solvent extraction separation, which will separate the rare earths into oxides that are in the individual elements based on however we want to target them. So whichever elements we're targeting. That is currently in operation in our pilot facility. The next phase, which we will be getting the equipment. So we designed the last phase, which is the reduction phase, which is based on a fluorination and molten salt electrolysis process. Will reduce the oxides to their base metal. This again is technology that is not existing on US soil. As of July, it will be here in our pilot facility. And so that's kind of the last phase. This is what China is doing and other countries that are importing the rare earths back to us for our end products. So the other part of this grant is what we're doing with this pilot facility is we are doing the front end engineering design for the larger facility. It's going to be what they're calling an intermediate scale facility that it's going to process 2,700 metric tons of clay into 1 to 2 metric tons of rare earth oxides per day, which then gets separated into the critical minerals and rare earths. So I'm not going to give you quantities there because there's just so many different products.
Understood. Yeah, understood.
But that is what we are designing right now. Our grant is going to be finished at the end of the year. And the goal essentially is to have a financial investment decision package, which this facility can go to either governmental or traditional loan sources. So source of equity, it could be private equity, could be traditional banking equity to basically fund the full detailed design and construction of this facility. So this, I would say, is probably one of the closest projects to actually be coming to fruition within the United States that is going to have the full process change of rare earth element separation.
So, and that's very exciting, Kim. And we'll separate and apart. We'll do a profile of that on rare earth exchanges to help get the word out. I want to come back to that. I want to go over to Paul just for a second. So all of this is happening in essentially what is central Pennsylvania, right? I mean, there's significant activity. So enter economic development. Talk about how your organization is looking at both what Sarma's doing, what Kimberly's doing, and what are you all doing to try to, and your colleagues, I know you're working with a regional group in central Pennsylvania. So how are you all trying to facilitate, foster, drive more growth in this area?
Absolutely. So, we had been hearing about this for a number of years, that Clearfield County had higher concentrations. And, from our perspective as economic developers, we're always looking for something different. What's unique about our community? Back in the 80s and 90s, you needed infrastructured land. This, everybody has that now. With the access to the internet, you can find locations with all the infrastructure. What makes you different? And when we heard the rare earth elements, it's like, okay, let's see, can we quantify that? What are the elements? Where are they located? And so it was really an educational initiative in the beginning. And, the big learning lesson for us was that rare earth elements are not uniformly distributed the way that coal is, or the way we have a long history of coal mining in this area. Next, we had conventional shallow gas drilling into the Oriskany sandstone and other formations with vertical drilling. Then we had horizontal drilling into the Marcellus region. I'm sure everybody's familiar with horizontal drilling and hydraulic fracturing, and what you're going to get when you drill into those formations. Rare earth elements are totally different in that they're not uniformly distributed. They're in different feedstocks. So we were saying to ourselves, okay, what feedstocks can we look at? They're in acid mine drainage. They're in waste coal, or bony piles, if people in the industry refer to them. They're in fly ash, which is the remnants of coal that has been burned in power plants. We have a coal power plant in this area. The underclays that Kimberly is focused on. Natural gas flowback water also contains this. So we have these elements. Next, so we have the source. That's a differentiator for our area of the United States. We also know that the market is in the United States. Look at all the different lists that the federal government puts out related to economic resiliency related to these. So from our perspective, we understood that we had both of those. We were missing the private sector in the middle that's actually going to extract and process these. So from my role, it was educating ourselves and then finding who are the players involved in this space. And I found out that we had the Center for Critical Minerals right next door, and I reached out and I saw that Kimberly and with Tetra Tech had been active in this space. And it's really our role is bringing all these parties together to show that we have the resources, we have the knowledge, we have the expertise. Soon we're going to have a pilot scale facility with the ability to supply the feedstocks. Now we're missing, and then I learned about rare earth exchanges and the work that you all are doing. And so we're hoping that this is how we're going to get solve one of the issues that's a national issue, not only for the economy, but national defense. So that's kind of our role, is bringing all these players together and showing that we're able to rise to the challenge and meet the needs that are demanded of us currently.
That's correct, and it was your organization, I think, that caught our attention. So I think you and I first connected. So yeah, this is great. I want to go back to Sarma in a minute, real quickly. Just make a comment. This is a national security matter. Make no mistake. And in fact, just to share what the imminence of all of this is the recent trade spat led to these controls over in China that pretty much are putting defense contractors really on edge, because we can't really talk about it, but it's happening. We have to move now, and this has been a problem for a couple decades. So it's time now that we actually act on it. So Sarma, back to you. I mean, based on where you're at now and what you've proven so far, what Kimberly's doing, what would be, from your vantage, the most effective, how could I say, the next steps in a project plan to make Central Pennsylvania a rare earth production zone based on this organic collaborative effort? That's what's happening. From your standpoint, what can the university do, Penn State do, to over the next, say, year, to help further this along?
Right now, what we are doing is basically building that pilot plant, and under one of the DOE contracts, core CM projects, we have characterized, as Paul and Kim have mentioned, in various counties in Pennsylvania. So we believe in more acid mine drainage. That is the lowest hanging fruit. If we have to tackle any solids, there will be a lot more energy. Again, that is what that's what Kim is doing, in the sense Tetra Tech basically is doing a pre-feed study. We are going to build this, and as a next phase, building this phase is congressional appropriation, and now the next phase, which we got from DOE, $5 million, is where we are partnering with three industrial folks, actually, over the next 3 years, already funded, where we produce this mixed rare earth oxides and also critical minerals mixed bag, and we give this mixed bag to rare earth salts for rare earth element separation. As Kim was mentioning, we need to separate these things into individual oxides or hydroxides or whatever it is. They're going to take care of that and separate them. And Aqua Metals, another partner for us, they have pilot scale facilities, demonstrated facilities, to take these critical minerals like cobalt, manganese, nickel, titanium, and lithium, and then they are going to separate them into oxides. And then University of Virginia, they have developed a low temperature metallothermic process, actually, and we are including that in this study also, to separate these oxides have to be reduced to metals to make alloys, and to go into magnets, to go into any of those things. So they are doing it. Finally, our partner, most important, and also the critical, is General Electric. General Electric is partnering with us to take these elements and make master alloys or super alloys that go into temperature environment, like gas turbines, and also magnet making, and test their properties, whether we can make these kinds of materials and what would be the results. So the idea here is to integrate all the technologies that are available right here in the United States and take the waste product and then turn it into some kind of a finished product, not some kind, finally, and test them domestically. And all these companies and all the individuals are United States people and the companies. So it would be a domestic technology, basically. That is what price. There are a lot of counties that have similar or even better or even some worse. As Paul was mentioning, the feedstock varies from place to place. That is the first thing that we have learned in our core CM project. So we are trying to demonstrate that indeed we can take this, and the sizing of the equipment, like if one feedstock has more iron or more aluminum or more rare earths or rare earth or whatever it is, we can fine tune our process so that we can make it here to make it much more robust for our technology. And then GE is going to perform a complete techno-economic analysis and also an LCA so that we know what it would cost. And I keep coming to this. This is something that I told DOE several times. Even yesterday, we had a meeting, and I'm telling everybody this. Abandoned coal mines, whatever water is coming out, whatever is happening there, who is footing the bill here? What is the payback period for that one?
Right.
Taxpayer is paying the money every cent.
Yeah.
So if we can use that burden little bit, that is rate of return. It may not be a private company that comes in, but they will also make some money. But overall projects don't have to be economically viable in the sense completely, oh yeah, 25% IRR on this project or 55% IRR on this. No, that is not what it is. We have to protect our environment, at the same time generate a revenue stream so that these things can be much more cost effective. I don't want to say this much profit or that much profit, but cost effective.
Well, yes, Sarma. I mean, your point is well taken that, there's this fixed investment already happening. And out of that process, we can extract these very mission critical elements. And what I want to say before going to Kimberly again is, Sarma, another thing that's very important for all of you to understand is that the training and knowledge, there's not, and some of the top people in the industry that kind of share with us information, advise us, tell us specifically about you all. We talked about you all, and they said, look, a lot of this stuff is going to need to be subsidized. We can go into that, but also there's going to need to be training, education centers, because there's very little talent in the United States that understands this. So as these pilots are showing results, another thing to do with government grants, for example, is like we want to become a center of excellence to train people, to show what's possible, because this labor will have to go out and work in these other mines and refineries and processes. Now, Kimberly, if you look at the next step here, the next 12 to 24 months, what would you like to have accomplished? If you're successful, your efforts are successful in 24 months, where are you guys at?
That's a great question. So just to kind of clarify, we are doing currently our front-end engineering design. We've completed all of our pre-feasibility, all the studies, that's done. We are rubber hitting the road right now. So within that time frame, what we are working towards is getting our production facility. It's labeled in DOE terms demonstration scale, but that actually is a kind of a misnomer. This is a commercial scale facility that will be producing a fair percentage of the national consumption of these rare earth elements and critical minerals. So that being said, our objective, as I said, by the end of the year is we are going to have our resource qualified. So part of our program right now, as you do with any coal operation that you're going to mine, is you go through a certification process of that reserve. And so we're certifying the first 12 years of operation right now through a drilling program, which is currently ongoing right now for that. And also we are going to be completing our front-end engineering design, getting our equipment bids, and getting our budgetary estimates for construction from actual contractors. So that's going out for solicitation. So the objective in the next 12 to 24 months is to actually get the equity we need to build the facility, which is going to be, right now, our current capital estimate is just under $500 million to construct it, with all of the things considered for the infrastructure. And we would like to have our detailed design finished and our permitting finished and start mobilization for construction. So, we are really at the point that we are looking to move along to actually build this plant and get it up and running.
Got it. And that's beautiful. And it's, again, great work. And I know we're pressed for time. I want to get one more in with Paul. But Kimberly, we're going to work with you separate and apart. Please reach out. We'll study the material of the project, and we'll try to help raise awareness so that you can try to accelerate the funding. So it's a very important project. Paul, so now with all of this unfolding, is that sort of what your organization is going to be doing as well? Are you reaching out to government grants or foundations or companies to try to help fund some of these important projects? Is that really what your focus is on the next 12 to 24 months?
Yeah. Not necessarily on the grant side of things yet, because we're still in the proving phase where once we get past demonstration scale. But where I'm at, I've been reaching out. So Pennsylvania has a network of international investments all around the world that are looking for investment projects to invest in Pennsylvania. Two countries in particular have shown a lot of promise because they're in this space as well. The top one, without a doubt, is Australia. Australia has several companies that are in the rare earth space doing some processing. We've spoken with them, and we're just, again, back on the education standpoint. We're trying to educate them on what we're doing here, shine a spotlight on this area. And also, we've had some interest from the UK as well. So there's some interest from companies there. So really, with our focus is just, we've kind of gotten to the point that people are understanding we do have the resource here. And again, I've been interfacing also with DoD, because at some point, if we're successful in getting these products separated domestically, we need to then find a market. And I don't think that's going to be that difficult. DoD, it's going to come down to what exactly is the product. And that's, it can be a whole topic of another discussion. But yeah, so we're, hopefully my job is going to be at some point, a company reaches out and says, we've learned about what you're doing. We have interest in investing here. Do you have a location that has full infrastructure? And can you put me in contact with the players in the industry locally? With two of them are on this call with us as well, along with some other players to look at building a commercial scale facility here and hopefully jumpstart that.
That's great. That's great. Well, I know we have a hard stop fairly soon. I wanted to just take a minute more each. This is sort of an existential threat. I mean, if you think about it, for the military grade stuff, we're 99% dependent on China right now. So, yes. I mean, and again, it's just, even if we were buddies with China, you still don't want to be that dependent on anybody. You want to be able to take advantage of what your own nation can produce. And I've been shocked, as we've learned about this space, it's amazing that we've gotten to this point. So Sarma, we think what you're doing is extremely important. Okay. And last question, we got to keep it to a minute each. Are you networking with other centers and other universities so we can kind of spread the knowledge? Do you have a national network? Is that getting some traction? People talking, Are there forums and such like that?
Yeah, definitely. We are in the DOE network with other universities, and in promoting, we have worked even in Consortium project with Tetra Tech, actually, with Tetra Tech private companies, as well as University of Kentucky, Colorado, School of Mines, and also Virginia Tech, who are all important players in this area. We respect, and also as a university, job is only to produce two products, which is basically the knowledge and dissemination of knowledge, workforce development for future. Definitely. So that is what we are doing actually as an institution. We train undergraduate students, we train graduate students, we retrain some of the workers in this business who are going to be employed. So that is our job as a university. So we are doing that, and we are connected in that respect. Actually, Paul has participated in some of our forums when we conduct these kinds of things. So yes, to answer your question.
That's great. And keep in touch, so the next time there is a forum, we can promote it, write about it, etc.
Sure.
Kimberly, you're partnered with other potential mine processing companies? I would imagine you have a pipeline of groups that you're talking to that might be interested in, I'm assuming. Is that the case?
Yeah, I mean, we are in a lot of conversations and connections with academia, with industry, with the mining sector. We've got a really tight relationship with several of the mining operators, as well as government, local, state, legislature, in order to get projects developed. Sarma started in academia, where he's developing the knowledge and the dissemination. I'm in the commercial sector. I'm in the job of getting projects built. That's where I'm at. And so my job is to make the rubber hit the road and take all the knowledge and make it into actionable work products. And so in order to do that, you've got to be connected with all the parties that are involved in the project development phase. So that's, the lenders, that's the off takers, that's the feedstock providers, that's the technology equipment providers, that's the construction contractors. We're the engineering, so I'm in touch with myself and my group of engineers doing the detailed designs. So yeah, and the state agencies for permitting. So there's a lot of conversations and moving parts, all with the end objective of getting this facility built in Clearfield County.
Yeah, that's fantastic. And again, as I mentioned, we'll help you with that. Paul, any last minute statements, Paul, about Clearfield County, about why Pennsylvania is special? And we can kind of go back to Dustin and conclude.
Yeah, no, I would just say for any listeners out there that may have interest in this, please reach out, because that is my goal at this point in time, is just connecting the dots. And as I mentioned earlier, I mean, we are looking at a regional perspective. So, just because I'm Clearfield County focused does not mean I'm not going to help you if you're looking at other areas. Like, we want to help get this going. And one of the stats that on my educational journey that was just shocking was just how reliant we are on particularly China for the processing. And, I guess the very last thing I would say would just be related to some of the challenges would be the de-risking of these projects. The private sector hasn't stepped in and filled that void because of either the cost or the environmental permitting. So that's where government could step in and say, we're going to help fund this to get this to a level that the private sector has de-risked it, and then you don't have to worry about that taking off. It'll take care of itself, if we can get to that point. So it's been a long process, but with your help and everyone on this call and the listeners, I'm confident we can get there.
I believe that. And remember, President Trump has a couple executive orders plus this 232 action where they're studying this situation. They'll come out with a report fairly soon, a preliminary report. So I wouldn't be surprised if Washington, D.C. knocked on the door somewhat soon. Dustin.
Great interview, you guys. Lots of great information, a lot of great questions. And for those that are listening, if you found this episode helpful, give the episode a like. If you don't want to miss a future episode, please subscribe to our channel and our podcast. And Kimberly, Sarma, Paul, thank you so much for joining us and sharing your knowledge. Hopefully, we'll have you on the show again in the future, get an update on your projects and the research that you're doing. I think it'd be beneficial just to kind of see how things are progressing, how things are changing, because this is important. So thanks again for joining, you guys, and we'll see you guys again soon.
Thank you all.
Thank you very much,
Thank
Justin.
you.
It's a pleasure, actually. So we'll be happy to share whatever we do. We are a public institution. Thank you.
Great. Thanks, Sarma.